Hi again, Year 11. So we're moving on today onto 10C, division of polynomials. Now, this is something I know I have shown some of you before in the classroom. And you're going to think way back to primary school, back in year 4 or 5 when you did long division. And you're probably thinking, oh no. Well, this probably is the first time you should do long division, and we're going to have a look at what you did back then and what it means and relate it back to your polynomial. So we're basically going to do long division of functions, divide one function into another. So if you have a look at the screen up here onto the right, I'm going to think, before I look at the more difficult stuff, think back over here. If I said to divide 146 by 12, back in primary school, you would have written it like this. How many times does 12 go into 146? And we would have gone, oh, okay, we think of your 12 times tables. 12 goes into 144 12 times, of course, if I put 12 up there. 12 times 12 is 144. Now, what you would have done if you did this in primary school is you would have come up with a factor at the top, multiplied it by the number that you're looking at dividing into your other number. Got a number here, so our 12 times our 12 gave us 144. You would have put a line underneath it, and then you would have subtracted. So 146, take away 144 is 2. And you would have gone and continued doing it. But that's the gist of what you would have done. So that's what we're going to have a look at today. But what we also want to have a look at is some of the terms that are written over here. So the number that we're dividing by, or the number that goes into our original number, or in our case, we're going to look at functions. The function that goes into our other function is called the divisor. So that number there is going to be the divisor. The number that we're trying to divide into is the dividend. The answer we get, or how many times it goes into it, is the quotient. And the number that's down here, if we can't go any further, if I can't pop 12 into 2, which I can't, 12 can't go into 2, it's my remainder. So that's the language that we're going to have a look at in this topic. And what we would actually say would be that it's not dividend, it's dividend. Our dividend, which in our case is 146, is actually equal to our divisor times our quotient, so 12 times 12, plus our remainder. So that's what we've basically done. We've said this dividend of 144 is equal to our divisor, which is 12, times our quotient, which is 12, plus our remainder, and our remainder is 2. So I'm just going to write that R as a 2. And that's what we've done. And that's what we're going to do over here as well. We're just going to write this in a particular way. So, there's this equation here. I could write it like that. I often write my dividend as my polynomial, p of x. So my polynomial is equal to my divisor. You might see it as b of x. I'm going to write it as d of x times my quotient, which is q of x, plus my remainder. Sometimes we won't have a remainder, and sometimes we will have a remainder. Okay, so let's have a look at this first example. So the first example is saying we want to divide this first polynomial, 4x cubed plus 8x squared minus 6x plus 7, by this other polynomial, x plus 1. We're going to use long division. So I need to just write that out. So I'm going to say, how many times does x plus 1 go into our polynomial here? Okay, so this is our polynomial. This is also called our dividend, our polynomial, and we're dividing in by our divisor. So let's see what we can do. So this one's going to be a little bit different to what we've done over to the right, primarily because we have two terms in our polynomial that's dividing in. So I want to see how many times does x go into 4x cubed, or what do I need to times x by to get 4x cubed? And then I'll write my answer up the top here. So I'm going to end up with 4x squared. I'm going to write it over top of that because 4x squared times x will get me 4x cubed. And that's what I'm trying to do, is come up with a term that will give me the first term of my polynomial, that is my dividend, because I'm going to then subtract like I did up here. So if you have a look what we did up here, we then subtracted. So my aim is to get rid of that first term when we subtract. So let's just go back down here. Okay, so I'm seeing how many times did x go into 4x cubed, and it's 4x squared, because 4x squared times x is 4x cubed. And that's what I want to do. I'm going to times my 4x squared by my x, and I'm going to end up with 4x cubed. But then I'm going to times this 4x squared also by my 1. I'm going to add that in there as well as 4x squared. Okay, so now I want to do, what I want to do, my next step is I want to subtract this line, subtracting the bottom line underneath it. So this polynomial, take away this polynomial. So what's going to happen then is I'm going to remove that first term. So 4x cubed, take away 4x cubed is nothing. Now we do my squares. 8x squared, take away 4x squared is 4x squared. You just have to be really careful with your negatives. Minus 6x minus nothing is still minus 6x, and the 7. So they're basically coming straight down. Okay, rightio. So we have our first term. We need another term. We need to now look at this polynomial in here, and we're dividing our x plus 1 into this 4x squared minus 6x plus 7. So we've basically reduced this first one down to here, and that's our first factor. That's how we've done it. We're going to repeat that process. So how many times does x now go into 4x squared? So we're going to see, well, what do I times x by to get 4x squared? And my answer will go up here. So if I pop in a 4x times x gives me 4x squared. So I don't need this part up here anymore. I'm now working below that line. So 4x times x gives me 4x squared, but I have a plus 1. So 4x times plus 1 needs to be multiplied out as well. We draw our line, and we're going to be subtracting this top polynomial, take away this bottom polynomial, and it's minus each of those terms. So if you've done it correctly, what should happen is this first set of terms are going to disappear. 4x squared, take away 4x squared is a nothing. Now, minus 6x minus 4x is minus 10x. 7 comes down because there's nothing there. Okay, can we do it again? We can. This polynomial that we're dividing in by is smaller than this here, so we can go another step. X goes into minus 10x. How many times? Minus 10. Because minus 10 times x will give me minus 10x. Minus 10 times 1 will give me minus 10. So again, what we've aimed to do is to get rid of this first term, but we need to do a subtraction in there. Minus 10 minus minus 10, which is minus 10 plus 10 is 0. That's what we want. 7 minus minus 10, which is 7 plus 10, which is 17. I can't go any further. X cannot go into 17, so I have my solution here. This polynomial here, underneath our sign, is equal to this one here times this one we've found out at the top plus our remainder. And I'm going to write that in that format. I'll just pop it over here to the right. So I'm going to say that my 4x cubed plus 8x squared minus 6x plus 7, which was the polynomial or the dividend underneath my divided by sign, is equal to my divisor, which is x plus 1, times my quotient, which is the part that I've worked out at the top, plus a remainder. Now, the only way to check that we are correct in this case is to actually multiply it out. I'm not going to, but if I was to multiply this polynomial here by this one here and add on my 17, I should end up with my left-hand side. So they're going to be equal. So let's see if we can have a go at another one. Okay, so if you scroll down to B on your notes there, what we've got here is just written in a different form. We've got x to the 4 plus x plus 1 divided by x squared minus 1. So we're going to write that out in a form that we can use just like this. In essence, this will be exactly the same. There's just a couple of little tricks to be aware of in this case, and I'll talk you through that as we get there. Okay, so we're looking at dividing x squared minus 1 into this polynomial with the power of 4. So I need to get a term up the top here. Something times x squared gives me x to the power of 4. It's going to be x squared. So x squared times x squared is x to the power of 4. X squared times minus 1 is minus x squared. Now, we're going to be subtracting the bottom polynomial from the top one. This is where there's a little something you need to be aware of. I can do the first step as I did before. X to the power of 4 take away x to the power of 4 is 0. But what you're noticing now is I have an x here and an x squared here. So what I want to think of is I need to subtract the x squared from any x squareds at the top, but there's no x squareds at the top. So there's basically what I'm thinking of is no x squareds take away a minus x squared. So there's nothing take away minus x squared. So nothing take away minus x squared is going to be plus x squared. So you need to be careful that you don't pop these two terms together just because they're underneath one another. If you like, when you write it out, you could have moved this bit over, but I guess you don't know that it's going to happen. So we've done the x squared term. Now we've got x take away nothing is x, and 1 take away nothing is 1. So just be careful that you are remembering to include that term in there. We're nearly there now. How many times does x squared go into x squared? It's going to be 1. 1 times x squared is x squared. 1 times minus 1 is minus 1. Okay, subtraction. So x squared take away x squared is 0. X take away nothing because there's no x at the bottom is x. And 1 take away minus 1 is 1 plus 1, which is 2. Okay, so I can't go any further in my division because x squared can't go into x. So I have a solution here, and how I can write that is x to the 4th plus x plus 1. So my polynomial under the brackets is equal to this one times this one. So x squared minus 1 times x squared plus 1. That's this one and this one times together, plus my remainder of x plus 2. Now that's one way of writing it. Another way we can think of writing it is slightly different, but writing it in terms of rational fractions. How we could write it, might just write that, we'll say in terms of rational fractions, same thing, just another way of thinking of it, is what I could write it as is x to the 4th plus x plus 1 divided by x squared minus 1, which is what we've done. We've divided this polynomial by this one, is equal to, we got an answer of x squared plus 1. That's how many times it goes into, plus x plus 2 parts of x squared minus 1. That's my remainder part. So how many times did x squared minus 1 go into our original polynomial? It went in this many times, but there were this x plus 1 amounts of that left. So they're the same thing. And if you think of it algebraically, all I've done is basically divided every term by x squared plus 1 in the equation before. This divided by x squared plus 1 gives me this term. This divided by x squared plus 1 just gives me that term. And this divided by x squared, minus 1, gives me this one. So they're the same thing, just written in a different format. And one last thing I just want to mention, which is, I think, pretty self-explanatory, but when we're looking at our theorems here and our long division, and we're having our polynomial, which is equal to our divisor times our quotient plus our remainder, and we'll use this as our example. When we're dividing through, the degree of our remainder, so in this case our degree is 1, needs to be less than the degree of our divisor. Because if it isn't, then we can always go another step further. So that's, I think, pretty self-explanatory, but something to keep into account or keep in mind. But also, our r of x, or our remainder, could also be 0. And if that be the case, and that is 0, then our polynomial we have our factors of our polynomial. We'll have d of x and q of x, and we'd have no remainder. So just note that it's okay to have a remainder, and then we just have perfect divisors that would go into that. That gives us some work for you to go on with 10C. Go and do the exercise. Back in the OneNote, as per usual, I've popped a tab in there for 10C, and I've started working through some examples and notes in there for you from the exercise to help you out a little bit more as well. So have a go at those. Let me know if there's any questions, and we'll talk about them in class.